Hello, people. In this session, we'll be continuing from where we left in our previous session. We will be discussing the concept of correlation coefficient and juxtaposing it with the statistical inferencing concept that we studied in our previous sessions. So basically, the main idea here is that we have been given a sample consisting of two numerical variables. What we need to find out, or what we need to estimate, the unknown population parameter here is the correlation coefficient between the two numerical variables within the population. And we have been given those same two numerical variables, but we have been only given a sample. So let's come to some basic notations first. So my unknown population parameter here is rho. This is the population correlation coefficient. What I have with me is R, nothing but my sample correlation coefficient. This is what we have. This is what we need to find out. Now, what we do over here, the methodology we use to estimate the population parameter from the samples is we have to solve this using t-distribution with n minus 2 degrees of freedom. So we will come to this part later on, but first we need to describe our null and alternate hypotheses. So this is my unknown population parameter, rho. On this, I will be setting up my null and alternate hypothesis. So my null hypothesis H naught will be rho is equal to 0. What this means is that my null hypothesis states that there is no correlation between the two numerical variables. My alternate hypothesis will be, so if you think about this carefully, we want to find evidence that there can be a positive correlation or there can be a negative correlation between these two variables. We are not concerned with the direction of the correlation. We are more interested in proving that there is a correlation in the first place. So we have to consider both cases, which means this will be my alternate hypothesis. So this is going to be my two-sided t-test with n minus 2 degree of freedom. Right? So now we will start solving this particular problem. This is a t-test. Then we know for a double-sided t-test, this is going to be my significance level. And we are interested in estimating whether my point lies in this region or this region. So this is what the basic concept of two-sided t-test is. You can do it in both ways. You can do it using the test statistic approach, or you can do it using the p-value approach. So let us try and solve a sample example. So let us take the same dataset that we had seen in the previous session. And also, before I move on to the examples, it is very important for me to tell you what the test statistic value here will be. The test statistic value here will be t is equal to r into under root of n minus 2 upon 1 minus r square. This will be the value of my test statistic. This we need to compare with the critical value. Now coming to my example, for the student data set, if I do an n-row student, I have 31 rows. My R value is my core value between hours and score. What is my R value? So this row for this particular problem represents correlation between hours and score. This is what row represents. This is already calculated. Now we just need to put this in the formula. The statistic value will be by SQRT the n is not found. We're going to initialize this. Let's see what my test statistic value is. It's somewhere around 10.331. Now, if someone asks me to basically test whether or not my result is significance at 95% confidence interval or 0.05 significance level or alpha level, so I have to calculate T critical. It will be QT. This is my 0.95. This is 0.025. This is 0.025. This is 0.975. So my area to the left of T critical is 0.95 plus 0.025, 0.975. N minus 2, this is my degree of freedom. So as I said before, this is a two-sided t-test with n minus 2 degree of freedom. Let's check the value of PCA. It comes out to be 2.045. So this comes out to be 2.0. Five. This is somewhere around 10 and 3, 3. So my t is greater than my t critical. Therefore, because my t is greater than my t critical, I can reject the null hypothesis. And I have sufficient evidence that my mu is not equal to 0. This is how we do statistical inferencing for correlation coefficient. Thank you all for watching. I'll see all of you in the next session. In the next session, we'll be starting with the basics of simple linear regressions. Thank you.